Eliana drove her car 81 kilometers and used, okay, so let's see, drove 81 kilometers and used 9 liters of fuel. She wants to know how many kilometers X she can drive on 22 liters of fuel. She assumes her car will continue consuming fuel at the same rate. How far can Eliana drive on 22 liters of fuel? Okay, so kilometers and liters of fuel. So she drove 81 kilometers and used 9 liters. Okay. So to go, how many kilometers she can go on 1 liter? So I divide 9 divided by 9, I get 1. 8 divided by 9, I get 9. So she can go 9 kilometers on 1 liter. She wants to know how many kilometers X she can drive on 22 liters of fuel. So to go from 1 to 22, I multiply by 22. So 1 times 22 is 22. And if 1 liter is good for 9 kilometers, so I need to multiply 9 times 22. Okay, so 9 times 20 is 180, and 9 times 2 is 18. So together is 928. 990, 198. 198, let me verify. 29 times 9. 9 times 2 is 18. 9 times 2 is 18 plus 1 is 19. 128. How far can Eliana drive on 22 liters of fuel? 198 kilometers. Figure A is a scale of figure B. Okay, what is the value of X? Okay, so the ratio between 27 and 45 45 divided by 27. Divided by 27 is 1. 1 times 27 is 27. Subtract. 4 becomes 3. 5 becomes 15. 15 minus 7 is 8. 3 minus 2 is 1. 27 doesn't go into 18. So I put here decimal point. 0. 27 goes into 180. Let's see. 9. No, that's too much. 8. 8 times 20 is 160. 8 times 7 is 50. No, it's too much. 7. It's too much. 6. Yeah, 6 is good. 6 times 27 is, this is 42. 6 times 7 is 42. 6 times 2 is 12. Plus 4 is 16. Okay, so 6 times 27 is 162. So we have a remainder of 18. So it repeats itself. So it's 16666. So I need to multiply 27 by 1666 to go to 55. So I need to multiply, to know what x is, I need to multiply 18 times 1.666 to know what x is. Or I can multiply 18 times 45 divided by 7. Okay, so let's see. 18 times 45 divided by, divided by 27, which is the same thing as 18 over 1, multiplied by 45 divided by 27. 18 divided by 3 is 6. 27 divided by 3 is 9. 6 times 45 . 5 times 6 is 30. 6 times 4 is 24 plus 3 is 27. So this is 270 over 9. Which is 30. Yeah, I could have divided 18 by 9. Okay, so 18 over 1 times 45 over 27. I could have divided 18 by 9, so 18 times 2. 27 divided by 9 is 3, so 2 times 45 is 90 over 3. 90 divided by 3 is 30. Yeah. So x is 30. Because if I multiply 18 by the ratio to go from 27 to 45, we need to multiply 27 times 45 divided by 27. To go from 18 to x, we need to multiply by the same ratio. When and then multiply 18 times 45 over 27, you get 30. So x equals 30. Tomer owns a daycare center called Kids Care. One afternoon, he collected the age of each person in Kids Care. The following histogram summarizes the data he collected. So this is age in years, and this is number of people. So kids age 0 to 5, there are 3 kids ages 0 to 5. There are 2 kids ages 5 to 10. There are 3 kids ages 10 to 15. One kid ages 15 to 20, and 1 kid ages 20 to 25. Kids Care. It's strange that there are kids ages 15. Okay, never mind. Based on this data, what is a reasonable estimate of the probability that the next person to enter Kids Care is between 10 and 15 years old? Okay, so how many people are represented in this histogram? So we have 3 plus 2 plus, which is 5. So this is 3, this is 2, this is 3, this is 1, this is 1. 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 1 is 9, 9 plus 1 is 10. Okay. Okay, so kids between 10 and 15, there are 3 of them. So 3 out of 10 are kids between 10 and 15. So the probability that the next person to enter Kids Care is between 10 and 15 years old is 30%, I guess. 3 out of 10, yes. Figure A is a scale image of figure B. Okay. Figure A maps to figure B with a scale factor of 0.8. What is the value of x? Okay, so x equals 0.8 of 5. Or it can mean x plus 0.8 of x is 5. So it's 1.8. Let's see if I take this. Put it next to. Okay, so it looks that x is 80% of, yeah. It doesn't look like 5 is 1.8 of x. But they mean that when they say with a scale factor of 0.8, yeah, that x is 0.8 of 5. And 0.8 of 5 is 0 is 4. Right? 8 times 5 is 40. Shift the decimal point one place to the left. So I get x is 4. So why do I need a calculator? Teresa is maintaining a campfire. She can keep the fire burning for 4 hours with 6 logs. Okay, so hours and logs. 4 hours, 6 logs. She wants to know how many logs. Why? She needs to keep the fire burning for 18 hours. Okay. She assumes all logs are the same. How many logs does Teresa need to maintain the fire for 18 hours? Okay. So let's see. To maintain the fire for 1 hour, I divide 4 by 4. So I go from 4 to 1. 6 divided by 4 is 1.5. 6 divided by 4. 4 goes into 6 one time. 1 times 4 is 4. And 2 remainder. bring them to 0. 4 goes into 20 5 times. 5 times 4 is 20, no remainder. Okay, so if I need to maintain the fire for 18 hours, I need to multiply 1 times 18 to go from 1 to 18. So I need to multiply 1 times 5 times 18 to know how many logs I need for keeping the fire for 18 hours. So 18 times 1.5 is 27, right? Because 18 times 1 is 18, and 1/2 over 18 is 9. 18 plus 9 is 27. So I need 27 logs. The Cinemania Theater showed 108 different movies last year. Of those, 15 movies were action movies. Based on this data, what is a reasonable estimate of the probability that the next movie is an action movie? Okay, so 15 out of 108 is so this is the answer, 15 out of 108. Thank you for watching. Okay, so I now will continue to the next section or unit, which is rates and proportional relationship, and in the next video I'm going to do this practice, rates with fractions. So I will see you in the next video.